We're now going to look at the process of halogenation, and that's when we use a halogen like chlorine, Cl2, and if we're going to use chlorine, then we would use FeCl3 as the helper compound here. It's not really a catalyst because it doesn't get reformed in the process, but we definitely need this in here in order to get the electrophile to form. And if we're using Br, then this will be Br2 and this will be FeBr3. So let's use X equals Br as our example. And if that's the case, then we'll have our FeBr3 and we'll have our Br2. Now what's special about FeBr3 is that it has no full octet. It's all it's got here is just the Fe with the 3 bromines connected to it, but it hasn't got 2 electrons here to complete its octet. It's characterized as what's called a Lewis acid. That is, it's a good electron acceptor, and that's what Lewis acids do. They accept electron pairs. So what can happen is that in order to fill its octet, it can react with Br2 in this fashion, and we can get this which is FeBr4 negative, which leaves us with a positively charged bromine as a counterion. And it's this Br plus here that is now going to be the electrophile, and that can react with the aromatic ring. So what we're going to look at is the aromatic ring now. And the electrons from one of the double bonds will react with the Br plus. These double bonds remain the same. Br will go here and the positive charge will end up on this carbon here. So the pattern looks like this. The bond reacts with the Br plus, or the electrons form a new bond between the C and the Br. And since this carbon here is effectively losing an electron because we're losing this bond, then it becomes positively charged. Remember in this bond that one of each of these carbons owns 1 electron in this bond, and if we use both electrons to form a bond with the Br plus, then what's going to happen is this carbon loses an electron, therefore becomes positively charged. Then we can lose the hydrogen that's on the same carbon as the bromine, and we're now going to reform our double bond, which brings aromaticity back to our system. And there's our bromination process.